So this video is about pathfinding in isometric view. We'll be using the constructs pathfinding, but we'll be filtering some of the results from it. The construct pathfinder is really meant to be used for orthogonal views, which is like top-down, and not so much with isometric. There are certain problems with it, and if you've used it, you will see it. I'll demonstrate it. If you go from one location to the other, you will notice that the way the paths are not quite straightforward. Like, it goes very close to this obstacle, then loops around, and you can see that it's kind of biased to basically straight lines, or rather orthogonal lines. So and in certain situations, these jaggedy lines here, or points, caused me some problems with animation because they were dependent upon the angle of movement. So what I've done is decided to use some sort of filtering in order to get a smoother solution. And the results look something like this. And so the principle here is it's still using the pathfinding of construct, but it's just filtering it out. So you can see that it no longer comes close to the fence, that really goes around, and it just looks a lot better. It uses move to, that's a Rex Rainbow plugin or behavior, and in order to get to the place, I obviously don't use the pathfinding move operation because there's no way to control. So the principle, how this works, is quite simple actually. It's based on line of sight, and what it does is that it gathers all the pathfinding nodes, and for each node, for example at the beginning here, it will trace all the other nodes that goes ahead of it and looks for the node that it loses track of, or rather it looks for the last node that it sees, and then that last node is then marked, and then from that node it looks again down the rest of the nodes ahead of it and sees the last, or spots the last node that it sees. And it continues, that kind of logic continues until you find yourself with these nodes that can see each other. So you get the minimum number of nodes, and you're able to go through the obstacle. And so very quickly, this is how it goes, or how it looks like inside the event sheet. So I won't explain the move to part, just explain the filtering. So the first part is basically to query whether or not the destination that's been clicked is within the line of sight. Within the player itself, I have a 360 line of sight that is used for that specific purpose. If the destination clicked is within line of sight, then it simply just moves to that location. So it doesn't do any more filtering. Now, but if it isn't, then it goes to this iteration where we first create one node where the player is, and then we start to iterate here through the next node in the list. But we don't really pick the node, we just simply query at the location of that node. Okay, so the node itself is going to check ahead of it, saying, okay, which is the next node that I can't see? If it sees it, if it has a line of sight, 360 line of sight, to that position ahead of it, then it ignores it. It only wants the part where it doesn't actually see the node ahead of it. I'll skip this, I'll explain this later. So in this segment, it's when it's lost sight. So if the next node is no longer visible, then we get the node just before it, which was visible to us, and then we mark that. That mark, which is actually loop A, that's like the index, is then used to create a node at that location. So another node is created, and then the loop is done again in order to find the next node that is visible, or rather that is not visible, then to get the node just before it. Now at the end of it, there's obviously, it's a loop, so it has to at some point stop, and it stops obviously where the number of nodes are counted already. So in the case where the check has found upon the last node, we always include the last node with the final solution to it. And basically that's how it works. We keep on scanning ahead of it, looking for line of sight, and then we just collect those ones that are within our line of sight, and then we collect it to an instance group, and from that instance group we use move2 to pop those individual sprites or objects and move to those locations sequentially. And so that's how it is. Quite simple. I hope you enjoy it.